All right, guys, so we're going to talk about 8.1 in this lecture. And in chapter 8, we're looking at basically some applications of trigonometry. So we're going to talk about the law of sines, then we'll talk about the law of cosines, and then we'll probably get into the trigonometric form of a complex number. And then if we have time, maybe polar coordinates. So the first thing is the law of sines. So these first two sections really are dealing with solving oblique triangles. Okay. Whoops. Solving. I already wrote that. Solving oblique. And so remember, oblique triangles are triangles. Finish writing this. Triangles that are not right triangles. Because we've already dealt with solving right triangles, right? Right? That's all an oblique triangle is. An oblique triangle is a triangle, not a right triangle. So there are a couple ways. There are different types of triangles we know, and you probably remember this from geometry class. So an example of an oblique triangle, this is angle, angle, side. So this is a type of triangle where we know two angles and the side that's opposite one of them. So, maybe we have triangle that looks like this, okay, and we know maybe that this is 96 degrees, maybe this is 23 degrees, and maybe we know that this is like 13 centimeters or whatever we're dealing with. So if you notice, I have two angles and I have a side that is opposite one of those angles. That's one type of triangle where if we wanted to solve this, right now we don't have the tools for that, right? Because it's not a 90 degree, there's no 90 degree angle. Of course, trigonometry is going to come up though. A SA is angle, side, angle. And that just means that we have a side that is between the two. So if I had this same triangle, 96, 23, then I would know the side that is in between the two angles. Okay, so that's what we mean by angle, side, angle. Another type is side, side angle. Make sure you do side, side angle, not angle, side, side. Don't know why I think that's funny every single time. So side, side angle, no, I crack myself up here. Side, side angle is where I know only one angle and I know the sides that are kind of opposite of them. So there's some issues here. In the side, side angle, there are some issues. We could have no solution. Like maybe we can't have a triangle that has that one solution. Or we could actually have two solutions. So when you see a side-side angle, two sides in an angle, you need to be careful here because we might actually know one solution, two solutions, or maybe there's no solution at all. So, if this was my 96 degree angle, then maybe I know that this is, 14 and this is 20 or something. So I know two sides in an angle, and the angle that I know is not the angle that is made up of those two sides. So we have to be a little careful with that one. Then we have side, angle, side. Okay, and we'll, that's kind of what you would think. That would be in this case, okay, now I actually, if this is 14, and this is 20, then maybe I do know, maybe that's 32. Maybe I do know the side or the angle in between it. Well, I do know that. And then 5 is side, side, side. So I know all the sides, but I know no angles. Okay, so what we are going to see is that to solve these, we are actually going to use, for these first three, we are going to use the law of sines, okay? And then for these last two, this will be in 8.2, we're going to use the law of cosines. So we'll do that when we get back from spring break. So the 1, 2, and 3 are going to be the law of sines, so we're going to work with that today. All right, so let's try something new here. Whoops. Okay, let's see. All right, so the law of sines. I'm going to prove this for you really quick. It's pretty easy to prove. You guys, I think you were saying you remember kind of how to do the law of sines. But again, we're going to take an oblique triangle. Don't pretend that all these lines are straight. You're pretty good at doing that for me now. And we'll just label these. This is A, B, and C. So of course this is little c, this is little b, or lowercase, I guess. And what I'm going to do, the problem with this triangle, right, is I can't do any sines or cosines, but this is the law of sines because I don't have a right angle. So what I'm going to do is I'm going to draw the altitude of this triangle, right, and make this a right angle. And I'm going to call this distance right here h, okay? So the way we get the law of sines, what would the sine of A be? Well, if I look at this small triangle right here, okay, so if I look at let's make it yellow. Ooh, that's what's kind of fun. Pretend that these are straight lines. So if I look at this yellow triangle right here, what does that show me? That the sine of A is h, right, opposite over hypotenuse. And then I have another triangle that's kind of hanging out here when I did that altitude. And that also says then that the sine of B is h over little a. So what I'm going to do is I'm going to solve this for h, and I like having h on the left-hand side. So I'm going to multiply both sides by h, and I'm going to do the same thing over here as well. I'm going to solve for h by multiplying both sides by a now. And now I have two different terms for h, so that means I can set them equal to each other. Okay, and now there are a couple ways that what we can do with this is I'm actually going to divide both sides now by not only the sine of A, but also the sine of B. Okay, because this is going to give us kind of a nice relationship. All right, so I'm basically dividing both sides by the same thing here. Whew, let's go. Whoa, that was white. That was kind of cool. I kind of liked that, but let's stick with my green here. And if you notice, these signs cancel, and here the B's cancel, and I'm going to put the A's on the left-hand side. And what this shows, the law of sines then basically gives us a way to relate the side of a triangle and its opposite angle. So we have A over sine of A, B over sine of B. And I could do the same thing with C if I like draw my altitude a little bit differently. So law of sines. Let's get a new page here. And we need to clear this one. So this is the law of sines. I'll give this to you on the test, but you probably won't need it. So I would have A over the sine of A equals B over the sine of B equals C over the sine of C. And this law of sines, we're not going to use all three of these equations at once. We'll just group two of them. So I might use, these first two, I might use these last two, or I might use the A equals C to solve some of these, okay? So example, solve the triangle if, let's say little a equals 4.56, A equals 43 degrees, and let's say C equals 57 degrees. So I just draw, whatever type of triangle you want. I try not make it a right triangle because I don't want to kind of mess myself up here. So what do I know here? What is my known? I know that A, which is the side opposite A, this is 4.56. I know that big A, the angle, is 43 degrees. And I know that C is 57 degrees. So the thing is, in order to use the law of sines, you need to have an angle on its opposite side. So I definitely have an angle on its opposite side. The first thing I would probably do is just go ahead and I would find B right now, because that's easy to do, right? I'm going to take 90 minus, oops, not 90, I'm not in a 90-degree triangle. Sorry about that. I'm going to take 180 minus 57 and minus 43. And I could probably do that in my head because I think 57 plus 43 is pretty nice. Oh, I put a plus. All right, there we go. It's 80 degrees. So that equals 80 degrees. So we'll just, you know, do what I have found in purple here maybe. So I found that B is 80 degrees, and now to find the sides of this, what I'm going to do is I'm going to use this relationship between sine of A and little a. Now, what am I going to try and find? I'm going to try and find little c. So sine of A, or excuse me, side A over the sine of A equals, so I'm just setting it equal to this guy here, little c, which I don't know, over the sine of 57, or the sine of c. And then you want to make sure your calculator is in degrees. And all I'm going to do is I'm just going to multiply both sides, right, by the sine of 57. So it's pretty easy to do. So I'm just going in my calculator, I'm going to take sine of 57, close my parentheses, times 4.56, divided by sine of 43, close my parentheses. This is pretty great. And I get C to be 5.61, okay? So C is 5.61. And so what's my last thing that I need to get? I need to get B. What I would do, I usually, I mean, I could use the relationship between C and C here, but I rounded this side C. So I'm going to go back to using this relationship between A. So I know A, 4.56 over the sine, sorry, this is a little messy, of 43 equals little b, right, over the sine of 80. Again, I want to use, I want to minimize rounding errors, so I just want to use maybe one that I've already had before. So again, I'm going to multiply both sides by sine of b, or sine of b, which is 80. So I'm going to take sine of 80 times 4.56 divided by sine of 43, and I get b to be 6.58. And so b is 6.58. Then I have solved the triangle, okay? Oh, and what type of triangle was this? It looks like it was angle, side, right? Because we didn't have the included side. So I have angle, side. I've solved everything I need to solve. The things, sorry, this is a little messy. I found little c, I found little b, and I found big B. Those were my unknowns. So pretty easy, I think. Law of signs isn't too bad until we get to the ambiguous case. So let's, of course it's easy until then, right? So let's really quick before we get there, let's look at another example. Okay, so let's look at an angle side angle. We can kind of angle side angles. So what if I had something like this, solve. Okay, and I'm gonna give you, oh, this one's a little bit, come on, undo, there we go. So this is almost 90, but not quite. Okay, and what do I know? I'm gonna say I know that, whoops, I know that this, let's say, is 89 degrees. So angle side angle, I'm gonna say that this is maybe 81 degrees. And then I know the side in between them, which let's say it's 120, whatever we're dealing with, okay? And again, this is an angle side angle because I have two angles and a side in between. So right here, I'm just gonna label this, and on your homework, they might give you different variables, like they might not do A, B, and C, they might do E, F, and G, or Q, R, and S, or something. I guess we can do that. Let's do Q, R, and S, so you get used to seeing this. So this would be little r, this would be little s, and this would be Q. If you notice, I can't use law of signs right now because I don't have an angle and its opposite side. R, I don't know little r. The other angle I know is S, and I don't know little s. So what I need to find is I need to find Q because I have its opposite side. So I'll take 180 minus 89 minus 81, right? And that 180 minus 89, it's going to be a pretty small angle. Yeah, 10 degrees. Okay, so I have found then that Q is 10 degrees. Now I can use that relationship between Q and little q, right? So I know 120 over the sine of 10 degrees. And now I can find whichever one I want. Let's find r. So I have little r over the sine of 89. Okay, and again, I multiply both sides by the sine of 89. So 120 times the sine of 89 divided by the sine of 10. And yeah, I figured that was going to be a pretty big number. R is 690.95. Okay, so you know, whatever, I don't know what our units are here, but maybe that's only inches or something, so that's not too much. Or I don't know, maybe it's feet or miles. I don't know what we're dealing with. And then how can I find S? You know, I could use the relationship between R and set it equal to the relationship with S. But again, that means I'm going to involve some rounding here. So I'm just going to use the same thing with Q. 120. There was no rounding when I dealt with Q. So I'm going to do S over the sine of 81 degrees. I'm actually just going to put second enter in my calculator and go in and change that 89 from before to an 81. Might save you a little bit of time. And what we get is S is equal to 682.5. Whoops. Sorry about that. 0.54. Okay, so S is 682.54. And I've solved the triangle. I have all of the sides and angles. Okay, those were the easy cases. So those were the easy cases. So the easy cases were angle, angle, side, and angle, side, angle. Here is the not so easy case. And why I say it's not so easy is we have this other, well, we had talked about it, side angle, side angle, where again, there's either no solution to this triangle, one solution, or two solutions. Okay, so I want to do a couple examples of this type. So in example 3, or example 3, I guess it is our example 3. Let's solve where we have, let's say A is 15, B is 28, okay, and so side angle, I don't have the included angle, is 43.6 degrees. So if I know when I write down this triangle, I'm assuming it exists. It might not exist, but let's see what we got. So this is 15, B is 28, and A is 43.6 degrees. Okay, so here's the issue. I can't find angle B or angle C, right? Because I only know one side. So what I need to do, I know the relationship between, 15 and its opposite angle. Now and here you're pretty much forced to try and solve for B, right? Because you know little b is 28 over the sine of big B. Okay, now what you can do here, you could cross multiply if you wanted to. What I just do is I flip each side, and sometimes I'll do that if I know I'm solving for an angle. The law of sines can also be written as like sine of A over A equals sine of B over B, because you can just flip both sides. Okay. I try not to encourage cross multiplication too much because, well, you guys wouldn't have a problem with this, but some of my students have issues with when they can do it. Okay, so I'm going to multiply both sides by 28. All right, I'm going to do that in my calculator. 28 times the sine of 43.6 divided by 15. And here's what we get. I get 1.287289815 equals the sine of B. And if you look at this, this isn't possible, okay? So it's not possible to actually take the sine of an angle and get something that is bigger than 1. So this has no solution. So what actually happens there? There are a couple ways you can look in your book. They give you a couple reasons why there's no solution, one solution. But what might have happened there is if this is just 15, right? Maybe that's 15, and I don't have enough length to actually connect this triangle if this is 43.6. Okay, so that's one thing that can happen. Or, you know, maybe one of these sides is too long to where if I have a certain angle, maybe this 15 is too long, and so I can't make a triangle that way. If you look in your book on 561, they show you like the different cases of having no solution. Okay, so a lot of times it's just because the dimensions that I'm given, right, because I'm not forcing, I have two unknown angles, I can't find an angle that's going to make that line right there to be long enough to join my other line here with only an angle of 46.3. If this angle could be brought down, right, this angle wasn't quite as big, then maybe I could bring that down and I could connect it or something like that. Okay, that might not be the exact case in this scenario, but I hope that makes sense. Let's try another one, okay, like this. So another side angle, but I want to look at one where there's one solution. So I'm going to write this like your book does. In triangle XYZ, x equals 23.5, y equals 9.8, and the angle x equals 39.7. Okay, so if I write this out, I kind of write it how they do it. Theirs is much better. This is 39.7, so this is x. That means this must be 23.5. We'll let this be y, this be z, and that says across from y is 9.8. Okay, so again, I'm going to take the relationship between the x's. I'm going to go ahead and put the sign on top because I know I'm solving for an angle. So I want my angles on top, 23.5, and I must use y, correct? Because that's the only other side that I have. So that says that the sine of y is to 9.8. So I'm going to multiply both sides by 9.8. Now you'll probably get to where you want to do this all at once in your calculator, but it's tough for me to do that on this video. Oh, this is good. I'm excited. I get 26637977707. I want to be as accurate as I can. Is the sine of y. So I take sine inverse of all of this. I'm going to be lazy. Equals y. So sine inverse of that last answer. Okay, so here's what we get. We get y to be 15.449, let's say. Kind of made that a little big. Now, here's the thing. This is what you have to do. Anytime you have a side-side angle, meaning you have two sides and the angle is not included, you must check to see if there's another solution. Remember, sine inverse, right, is only going to spit out angles in the first and the fourth quadrant. So where else? Now look at this number right here. This number right here is positive. So remember when we were solving trig equations in 7.5, we looked at, if I asked you for all solutions to this equation between 0 and 360, you would have to find the angles in the first and the second quadrant because that is where sine is positive. So I have to consider this 15.449. Where is sine positive, people? Sine is positive in 1 or 2. So if I take this angle, I could take, it gives me 15.449. That's what my calculator is going to give me. But I could possibly, my angle y could also possibly be the angle whose reference angle is 15.499, right? So I take 180 minus 15.449. I said that wrong, didn't I? You'll forgive me. And I have this other possibility for y. 164.551. And I need to check. Now, I told you this was only going to have one solution, so this is going to be our solution, but I now have two possible angles. Again, why is this a possibility? Because if I take the sine of 164.551, I get the 0.266 blah, blah, blah. So this might be one of my angles, and this might be also. And then I might have two triangles that satisfy this. You must show me this check, okay? So now I'm going to check this one. Check. How would I check to see if this is a possibility? Well, I'm going to look at what x is, right? I know that x plus y plus z must equal 180 degrees. Well, if x is 39.7 and y is 164.551, does that leave enough for z, right? That's the question. Does that leave enough for z? Well, it actually doesn't. If I take 180 minus 164.551 minus 39.7, I get a negative 24.251, which obviously it can't happen in a triangle. So what we do is we throw this solution out. My 15 is going to be fine. My 15 plus 39.7 isn't going to be an issue for me. So I have to throw this possibility out, and I'm just going to go with this angle for y. So I get 15.4. I'm going to do 15.45 now that I know that that is my only solution. Okay, I have to see this check. If you don't want to show me the check, this is what we call the ambiguous case, or the, that word's really hard for me to say, but this is the ambiguous case where we don't know if that's the only solution. So of course, in my next example, I'm going to show you one where it's not the only solution. Okay, so I have that y is 15.45. I can find z, right, by just taking 180 minus 15.45 minus 39.7, and I get z. This one's going to be fine because 15.45, I see that my decimal's off, but my decimal should be there. We get z to be 124.85, which is fine. Okay, so this is 124.85. And now I'm going to use the law of sines again to solve for little z, and I'll be done. So I have little z over the sine of 124.85 equals, well, I'm going to use my x's again because my x's together didn't involve any rounding. So 23.5 all over the sine. And notice how I put now the sides in the numerator. 23.5 times the sine of 124.85 divided by the sine of 39.7. That tells us that z is about 30.19. And so I have solved the triangle. Yay. Okay. Hope that makes sense. You have to check. Why do we have to check again? Because when I bring in sine inverse, the possibility is that it could be in 1 or 2. And your calculator, your sine inverse for your calculator is only going to give you an angle in quadrant 1. But I can have angles of a triangle that lie in quadrant 2. That just means that I have an obtuse angle in my triangle. Okay, so let's do one where there are two solutions, and then we'll call it good. Okay, two solutions. So in triangle ABC, let's say that B is 15, little c is 20, and big B is 29. Okay, so I don't know. I just told you that this was going to be, it's going to work. Let's let this be A, B, C. 15 then, 29 degrees, and little c is 20. So I can only hope for little or big c. So sine of c, again, I'm putting the signs on top because I know I'm going to be solving for an angle. So I get sine of c equals 20 times the sine of 29 divided by 15. Obviously this part of the test will be on the calculator part. I am not so mean as to put this, well, I don't think we'd be able to do it if it's on the non-calculator. So c equals sine inverse of this stuff here. Okay, and so what do I get c to be? I get c, one possibility for c is 40 point, let's round this out a little bit more for my final answer. I'll stay you know, I won't round it out quite so far. So, two possibilities, okay? There are two possibilities. So, let's look at solution 1. Okay, C is 40 point, we'll just round it to 7. And then solution 2. Well, I told you there were going to be two solutions. So how do I know there are going to be two solutions? Well, I know A plus B plus C must equal 180, right? So I know this 40 is going to be fine. If I add 40 to 29, I get a number that's less than 180, so I will be able to find A. But what is my other possibility for C, right? My other possibility for C is the angle in quadrant 2, whose reference angle is 40.27. I'm not going to write it all out, 2717. So I'm going to take 180 minus 40.2717. And I get the other possibility for C is 139.73. Now, is this going to work? So I'm going to check. I know this guy's fine. Let me check the 139. So will that give me enough degrees left for angle A? 73 equals 180. So what does that allow for A to be? 180 minus 139.73. minus, what's my B, 29? Yeah, this is fine. That would give me A to be 11.27. So we're good. So in this case, A would be 11.27 degrees. Over here, if I take 180 minus 40.27 minus 29, which was my B, I get 110.73 degrees. So these are my two solutions. I have two different triangles that will satisfy the given requirements, okay? So I have A, C. What's the last thing I need to find? I need to find little a. So in this case, I would take little a over the sine of 110.73. And I'm going to go back to using, I'm going to use my B just because, again, I didn't round. That was 15 over sine of 29. 15 times the sine of 110.73 divided by the sine of 29. Excuse me. All this talking straight makes my voice kind of tired. So I get little a to be 28.94. I'm going to do the same thing over here, except I'm going to use my other possibility for A, 11.27. But I can use the same thing for B. B is the same in both triangles. So 15 times the sine of 11.27 divided by the sine of 29. And this case, little a is 6.05. So these are my two solutions to this triangle. There are two triangles that Sorry about that. I don't know what you saw. I don't know how I made my screen go blank. You probably just saw this and my screen went blank. I didn't know what happened. All right, so these are the two solutions. There are two triangles that satisfy this requirement right here. Hope that makes sense. Of course, do the fun sheet, start working on your homework, and when we get back from spring break, I will obviously answer any questions you have about the law of sines.